So in this video, we're going to continue with Newton's second law. I'm going to do a few examples so you can get refreshed on some problem solving strategies and habits. So what I have here is the handout that you were given earlier in the year. This is just the front page of it. It has Newton's second law there and some class problems, and it goes on for a few pages, and we did a whole bunch of problems, but that was a long time ago, and I just want to do a few now, just to review and just to give you a refresher. All right, so here's the first example. It says determine the acceleration of an 8 kilogram object if its free body diagram is shown below. I apologize if some of this is messy, but all right, so it says determine the acceleration, and for Newton's second law, our formula is acceleration equals the net force divided by the mass. And when I look at this formula, it says find the acceleration, so it's already isolated for the acceleration. There's mass in it, and I see in the question that I have the mass, and then I need to find the net force. I'm going to use the free body diagram to find the net force. So just looking at this free body diagram here, I see that I'll just do it the long way here. I would normally do most of this in my head, but I'll say I've got 40 newtons up plus 40 newtons down. Okay, so that's this one and this one, plus 30 newtons right, plus 15 newtons right. So that's these two right here, and then plus 10 newtons left. And when I add all that together, the 40 up and 40 down cancel each other out. And then in terms of right and left, we've got 30 plus 15 makes 45 newtons to the right. And then plus 10 to the left. Plus 10 to the left, I can replace that with minus 10 to the right. Okay, so 10 to the left is the same as negative 10 to the right. So when I add those together, it's really just going to be 30 plus 15, which is 45, minus 10, which is 35 newtons to the right. So now I have all that I need to get the acceleration. The acceleration is simply the net force, 35 newtons right, divided by the mass of 8 kilograms. And then I get my calculator out for that, which I don't have, but this one's not too bad, 4.375. The units would be, you see in the equation, it might be newtons per kilogram, but I know that the SI units for acceleration are meters per second squared. The direction would match whatever I had in the previous line, which is to the right. And I'm just going to round this to 2 significant digits based on our significant digits rule. Alternatively, I could just underline 2 significant digits in my answer there. All right, so that's how I would do this question. The next question says, Michael is pushing a 20 kilogram box to the right against a frictional force of 60 newtons left. If the box accelerates at 0.50 meters per second squared, determine Michael's applied force. Okay, so I'm not given a diagram here. This is a bit of a longer question, so I'm going to apply some of my strategies and habits here. I'm going to make a list. I'm going to make a list of everything that I'm given in the question, which is the mass, 20 kilograms, the frictional force, of 60 newtons left. And the acceleration, which says 0.50 meters per second squared, and it actually does not say which direction that is, which is kind of important. So I'm going to throw that back into the question. Sorry about that. Okay, we're going to say the acceleration's towards the right. Okay, and then it says determine Michael's applied force. I'm going to add that to my list as well as a question mark. So FA equals a question mark. Okay, so to solve this, I think of any formulas that might be relevant. I could sketch out a diagram if that'll help me. Basically what's going on here is I've got an applied force to the right, which I don't really know how big that is, but I know that it's bigger than my frictional force to the left. And my frictional force is 60 newtons. Okay, I know that my applied force has to win because the acceleration's to the right, so the net force has to be to the right as well. There's gravity and normal as well, but they cancel out. I'm not going to draw that in here. So in order to solve this, I go to my formula. There's really only one so far for this unit, Newton's second law, right there. And I look at my list and I think I have my acceleration, I have my mass. That's going to allow me to find the net force. That's helpful. The whole goal of this question is to find the applied force at the end. So what I'm going to realize is that my net force, in this case, the magnitude of it is going to be the magnitude of my bigger one, the applied force, minus the magnitude of my friction. Okay, so I'm actually just going to replace that where net force is in the formula. It's going to look like this. Okay, so I just replaced the net force with the applied force minus the frictional force, and I did everything in terms of magnitudes. It's just more intuitive for me personally doing it that way. All right, so then my goal is to figure out the applied force. And I'm just going to rearrange the equation for applied force. So I'm just going to do it all in one go here. What's going to happen is that mass is going to be multiplied on both sides, giving me mass times acceleration. And then I'm going to add the force of friction on both sides. Okay, so I skipped a lot of the steps in between there. I skipped writing them out, but this is the rearranged formula for applied force, and I can plug in the values there. 20 for mass, 0.50 for acceleration, and then 60 for friction. I calculate all that out. That's 70. And then I'm gonna check for significant digits, and I think everything is good there. And then I'll throw in the units, which would be newtons. Now for my final answer, they're asked for a vector, so my applied force is 70 newtons, and I'll add the direction based on my diagram. It's to the right, and that would be my final answer. Okay, so there's a second example, which is a bit more complicated than the first one. And then my third example is a little bit more complicated as well. So it says a net force of 600 newtons east causes an object to accelerate from rest to 4 meters per second east over a displacement of 24 meters east. Determine the mass of the object. So an object starts at rest, and then somebody pushes it, or a net force pushes it, and it causes it to speed up. It causes it to accelerate. And it says that it arrives at so after it traveled 24 meters, it has sped up to 4 meters per second. All right, and we have to find out the mass of the object here. So same way to start. I'm using my strategy of making a list. So I've got the net force, 600 newtons east. I've got that it starts at rest, which I'll write as V1 equals 0 meters per second. I've got the final velocity of 4 meters per second east. And I've got the displacement of 24 meters east. Okay, so I'm given all of that. My goal is to find the mass. Okay, it says determine the mass. And now you may realize that we're going to have to bring in some Unit 1 material into this. So far, the only formula I have in Unit 2 is Newton's second law. However, my list has all these other variables in it. It's got velocities and displacements. So I'm going back to Unit 1. And the big link, the big connection between Unit 1 and Unit 2 is acceleration. What I'm going to do is I'm going to try to use all this information here to find the acceleration. Okay, I can do that with my Unit 1 formulas, and then once I know the acceleration, I can go back to Unit 2, use the Newton's second law formula, and get the mass. Okay, so I'm going to find the acceleration first. So if I were doing a problem set, I would use headings so that the reader knows what I'm doing. And that I'm not just, when I'm marking it, I don't just have to look all over the page and all of that. In a problem set, you'd also have to explain everything as well. We'll talk about that again later, remind you of all that. Okay, so to find my acceleration, you want to look back into your Unit 1 formulas. So you may have to get out the handout for that, or get out the formula sheet or something. They're normally posted at the front of the classroom. So the formula that's relevant, I'll just write it out. But you definitely want to make sure you find the formula sheet. Okay, this is the one that's going to allow me to get the acceleration. I'm going to cross out v1 squared because the value is 0. I'm going to isolate it for acceleration. I would just divide both sides by 2 displacement and fill in the values. So that's 4 squared is 16, divided by 2 times 24 is 48. So I'm looking at 16 over 48, which is a third. So what I'll do is I'll just write 0.3333. It's repeated, okay, in the calculator. I'm just going to keep a couple of extra digits and underline 2 significant figures to keep track of it. All right, now I have the acceleration. I can find my mass. Okay, so go back to Newton's second law. We're going to rearrange this for the mass. Basically, acceleration and mass will swap places in the formula when you rearrange it. And I can fill in the values. 600 divided by 0.3 repeated which is really large. It's 1,800 kilograms to 2 sig figs. That's quite large. Oh well, that's going to be the answer. All right, so if you go on Google Classroom, you'll see I've also posted a worksheet with some practice questions. I've also posted the answers to those, the final answers only. So if you have trouble, you do them and your answers don't match and you can't figure out why, you're going to have to try to contact me somehow. You can email me, that's probably the easiest way. All right, then you can look forward to Newton's third law next.